for this integral, what you can do is just try to rearrange it so you can use u substitution. So I see that on the top there's 2 for both of these, so I can pull that 2 out. And then from there I can pull that 2 out even more out of the integral. So now what I can do is I see that these 2 might be related. So I set the u as the denominator, so it's going to be e to the x plus e to the negative x, and the derivative of that will be e to the x, the same thing, plus e to the negative x, so that's going to be e to the negative x times the derivative of e to the, to the negative x, which will be -1, so it's going to be minus e to the negative x. So we look, is that represented in the actual integral? Yes, it is, because over here we have the exact same thing. So now we can represent everything in terms of du and u. So it's going to be 1 over u squared, because I said u was the denominator. And then du represents dx, so that represents all of this, and then we keep the 2. So now I will rearrange this so we can do the integral of this function. So if you have 1 over u to the 2, you can rewrite that as u negative 2. These two are equivalent. Now what you can do is actually do the integral. So the integral of u to the negative 2 will be, you add 1, it'll be plus 1, so it'll be u to the negative 1, and then it'll be multiplied by the same thing, 1 over whatever this is. So it'll be 1 over -1, which is the same as -1. So all I did was just add 1 to this, so that gets you -1, and then multiply it by 1 over this, 1 over -1, which is the same as -1. So it's 2 times -1, because the 2 comes from here, 2 times -1 is equal to -2. U to the -1 is the same as 1 over u, so it's going to be -2 over u plus c, always remember the c. And then finally, we have to substitute u, and I said u was e to the x plus e to the negative x. So that's what I do, I just plug that in, and this will be your final answer. I hope that helped, and thanks for watching.